Now number 8, it says find the length of an arc in a circle of radius r intercepted by a central angle theta. Round the answer to 2 decimal places. So the formula for using or for finding arc length was S equals r theta, and theta must be in radians for this to work. So if we take a look at this question over here, say part A, where it tells us r is equal to 7 and theta is equal to 55 degrees. The first thing I'm going to do is take 55 degrees and convert that into radians. So again, to do that, it'll be 55 degrees times pi over 180, which would look like 55 pi over 180, or 11 pi over 36 in radians. And then we can calculate arc length by the formula. So it would go S equals R7 times theta, 11 pi over 36. And that's going to be 77 pi over 36. But I went ahead and threw that in the calculator and rounded it to the nearest 2 decimal places to get 6.72. It's also important to recognize this is length in centimeters. So 6.72 centimeters. Now looking at number 9, it says solve the right triangle for all missing sides and angles. So we know one angle, we know 40 degrees down here for this angle. We can figure out the missing angle of A up above by doing 180 degrees minus 90 degrees, since it's a right triangle, minus 40 degrees. We'll be left with 50 degrees here. So that would be angle A. Now, if we want to find one of the missing sides, we do know side C is 22. That's going to be our hypotenuse here. If I use angle 40, then this would be the side adjacent, and this would be the side opposite here. So I'm going to start off by finding side A. To do that, I'm going to use the cosine. Since cosine is equal to adjacent over hypotenuse. For this, it would turn into cosine 40 degrees equals A over 22. And then when I multiply here by 22 on both sides, it would make this look like A is equal to 22 cosine of 40 degrees. Now I'm going to use the calculator in degree mode. I'm using degree mode since I'm working with degree measurement for the angles. And I'm going to go ahead and round this to the nearest second decimal place to get 16.85. Now to solve for side B, as an example here, I'm going to use the sine. So if I use the sine theta, that's because it's opposite over hypotenuse. The side I'm solving for is the opposite. So it look like sine 40 degrees equals B over 22. Same basic idea from the last solution. We can multiply. Solve for B is 22 sine 40 degrees. And when we approximate that, it comes out to be 14.14. Couple of word problems listed here. Let's take a look at part A. It says a kite is currently flying above the ground, 20 meters above the ground. The angle of elevation from the ground to the kite is 30 degrees. Find the length of the kite string to the nearest meter. Okay, so it helps to sketch out a picture here. So here's the ground. Let's use a level ground. We measure the angle of elevation up from the ground at 30 degrees to the kite up here in the air. And so that altitude is 20 meters. We'd like to find the length of the string connecting to the ground. So I'll just label my sides here A, B, and C. And so we know that we have the side adjacent, side opposite, and the hypotenuse here. And if I'm trying to solve for the hypotenuse, I know the opposite. So what I'm going to use here is the sine, since the sine has the opposite over the hypotenuse. So that would look like sine 30 degrees is the opposite 20 over the hypotenuse C. Now I have to solve for C, so I'm going to multiply both sides by C. C sine 30 degrees is equal to 20. And what I'll do here is I'll divide both sides by sine 30 to get C is equal to 20 over sine 30 degrees. And when I use the calculator to approximate that, it comes out exactly, not approximately in this case, but exactly 40 meters.